This is the brain stem, in which we saw the lower part medulla. This is the pons, and above pons, this is the midbrain. Now this is the ventral or anterior surface of the pons. On the anterior surface of the pons, in the midline, we can see there is a groove or a sulcus. This is known as sulcus basilaris. This sulcus basilaris lodges basilar artery, and there is a cistern related in this part known as the pontine cistern. So this is the sulcus basilaris. On each side of sulcus basilaris we can see longitudinal elevations, one on this side and the other on this side, deep to which run the descending corticospinal fibers. We can see on each side there are transverse striations on the surface of the pons. These are the transverse pontine fibers. The transverse pontine fibers, they emerge from the pontine nuclei situated within the basilar part of pons and go to the cerebellar hemisphere via thick peduncles. So this thick peduncle is the middle cerebellar peduncle. So you can see the middle cerebellar peduncle on each side. This is the middle cerebellar peduncle, which will connect the pons with the cerebellum. At the junction of the ventral surface of the pons and the middle cerebellar peduncle, this is the site of the attachment of the trigeminal nerve. The trigeminal nerve arises on the ventral surface of the pons at the junction between the ventral surface and the middle cerebellar peduncle. The trigeminal nerve has two roots. There will be medial smaller motor root and a lateral larger sensory root of trigeminal nerve emerge at this location. Whereas at the pontomedullary junction there will be attachment of three cranial nerves from medial to lateral, abductor nerve, facial nerve, and the third one which we can see here is the vestibulocochlear nerve. The pons is divided into two parts. This ventral part, convex part, curved from side to side, this part is the basilar part of the pons, whereas the posterior part of the pons is known as tegmentum. The posterior surface of the pons, it forms the upper part of the floor of the fourth ventricle. So this is the posterior surface of the pons, which forms the upper part of the floor of the fourth ventricle, whereas the lower part of the floor of fourth ventricle is formed by the upper open part of the posterior surface of medulla oblongata. So this is the floor of the fourth ventricle, in which we can see in the midline there is a sulcus known as the median sulcus. So this is the median sulcus, and this diamond shaped fossa is known as rhomboid fossa or the floor of the fourth ventricle. The inferior angle of this fossa is known as the obex. So this point here, inferior angle, it is known as the obex. This is the median sulcus. Now here we can see there are transversely running white fibers across the floor. These fibers are known as stria medullaris. The stria medullaris fibers divide the diamond shaped floor into two triangles. This is the upper triangle, which is formed by posterior surface of pons, and the lower triangle, which is formed by the posterior surface of upper open part of medulla. The fibers of the stria medullaris arise from the arcuate nuclei. The arcuate nuclei are located anterior to pyramid, and the fiber arising from arcuate nuclei, they run dorsally through the substance of medulla oblongata and then across the floor of the fourth ventricle to the opposite side and go via the inferior cerebellar peduncle to the cerebellum. So these fibers are the stria medullaris. Below stria medullaris, that is a part of the medulla oblongata, we can see two smaller triangles. One, the medial triangle here, whose apex is at obex. So this triangle is the hypoglossal triangle. Beneath hypoglossal triangle is situated the hypoglossal nucleus, which is a motor nucleus. Lateral to this triangle we can see another triangle here, whose apex is directed up. So this triangle is a vagal triangle. The apex of the vagal triangle, which is a depressed point, is known as inferior fovea. So this is the inferior fovea. So here now we can see clearly on each side medial triangle, this is the hypoglossal triangle whose apex is down, and the lateral triangle whose apex is here facing up. This is vagal triangle. Deep to vagal triangle is located dorsal motor nucleus of vagus, which is a parasympathetic nucleus. Now here between gracile tubercle, this is the gracile tubercle, and the vagal triangle there is an area. This area is known as area postrema. Area postrema is a vomiting center and it is devoid of blood-brain barrier. So there is no blood-brain barrier in area postrema. When we see the upper part of the floor, on each side of median sulcus, we see longitudinal elevation. This is medial eminence. This is medial eminence. Lateral to medial eminence, we can see again a depressed point. This is the superior fovea. This is the superior fovea. And lateral to medial eminence, this imaginary line, lateral to medial eminence, and joining superior fovea with the inferior fovea, this is the sulcus limitans. So here we can see on each side, this is the sulcus limitans, joining superior fovea with inferior fovea. Medial to sulcus limitans will be the motor area, and lateral to sulcus limitans is the sensory or vestibular area. In the lower part of the medial eminence, there are rounded elevations on each side. So this rounded elevation is known as facial colliculus. So this is the facial colliculus. Beneath facial colliculus, we can see the fibers of facial nerve winding around the abducent nerve nucleus, and because of that it produces surface elevation, that is the facial colliculus. Also here in this part, upper part, superior to superior fovea, this area is bluish in color. This area is known as locus ceruleus. So these are the important features in the floor of the fourth ventricle.